Alright, so I'm doing a video on absolute value, and this is absolute value equations. I'm not sure what you may or may not recall from previous lessons, but absolute value is the positive distance away from zero. So for example, if I'm at positive 2, you can see that I am clearly 2 units away from zero. Similarly, if I am at negative 2, I'm also 2 units away from zero. Therefore, the absolute value of negative 2 equals 2. And the absolute value of positive 2 equals 2. A lot of people just say, oh, well, the absolute value is just a number without the sign, which isn't really a good definition. So I'm going to give you one more. The absolute value of x equals a. If x is greater than 0, then x equals a. So for example, the absolute value of x equals a, and I said the absolute value of 2 is greater than 0, so a would be 2. However, if I did the absolute value of negative 2 equals a, well, it says if x is less than 0, which in this case it is, it's negative 2, then x equals negative a, which would be a negative 2, which is 2. So once again, it kind of just goes back to this picture, which I'm hoping kind of makes sense. Alright. Now, to solve an absolute value equation, we do it very similar to a lot of the other equations we've actually looked at. The very first thing is we're going to isolate the absolute value. We're going to isolate the absolute value sign. Oh, goodness me. I don't know why I keep doing that. So here you can see, here's my absolute value, and this is my unknown quantity, right? The whole thing, it actually sometimes helps to think of the whole quantity as my unknown. If we just had 3x plus 5 equals 17, you'd have no problem solving that. So, oh goodness me. So what I'm going to do is this. I'm going to subtract 5 from both sides. And I'm left with 3 times x minus 2 equals 12. And once again, that's what we would do here. And then I would divide by 3. And so now I have the absolute value of x minus 2 equals 4, because 12 divided by 3 is 4. Oh, goodness me. Alright. So now, number 1 is done. Write 2 equations. So, this goes back to what we were saying before, and now I'm going to say, well, x minus 2 equals 4 if x minus 2 is positive. It was greater than 0. This quantity is greater than 0, but we don't know if it is. So we're going to write down x minus 2 equals negative 4, and that's going back to this. And I do want to make sure that you actually at least get the understanding, because it is kind of important. So there's 2 possibilities. So now I'm going to add 2 to both sides. I get x equals 6, add 2 here, and I get x equals negative 2. So if we take a quick look, if I plugged in, I'm going to go back, here's my original equation. If I plug in 6, I get 6 minus 2, which is 4. I get 3 times the absolute value of 4 plus 5. Well, that's just going to be 3 times 4, which is 12, plus 5, which equals 17. So that works. If I do something similar, and I put in a negative 2, plus 5 equals 17. Well, what we'll notice is we get 3 times the absolute value of negative 4 plus 5, but that's really going to be 3 times positive 4 because it's the absolute value of a negative 4. And we just said that 3 times 4 is 12 plus 5 equals 17. And so you can see it does check, and that's all we need for that. So there's one example. I'm going to do another example. And, oh, goodness me, I almost forgot. So now we have to write our solution set. We're going to use these curly set notation brackets to represent our solution set. So our 2 solutions are negative 2 and 6. Alright, I'm going to do example number 2. As soon as I can erase all this. In case you're wondering, my children are not yelling at me right now because they are in bed. So in case you're wondering where my comrades are, that's where they are. Here's example number 2. 2 times 2x plus 4. The absolute value of 2x plus 4 minus 4 equals 12. Once again, if I had written this, 2 times a minus 4 equals 12, you know exactly what to do. So I'm going to do this. I'm going to add 4 first. This comes on down. And then I'm going to divide by 2. That goes away. So now I have the absolute value of 2x plus 4 equals 8. Well, I've now isolated my variable. I'm going to write my two equations. I'm going to say 2x plus 4 equals 8, or 2x plus 4 equals negative 8. Subtract 4, I get 2x equals 4. Divide by 2, I get x equals 2. Here I'm going to subtract 4 from both sides, just the same. Get negative 12, I'm going to divide by 2, and I get x equals negative 6. And so my two solutions are negative 6 and 2. And you should check, if I plug a 2 in, 2 times 2 is 4, 4 plus 4 is 8, 2 times 8 is 16, minus 4 is 12. Plug in negative 6 and I get negative 12 plus 4 gives me a negative 8. What's the absolute value of negative 8? Which gives me positive 8, which makes it work. I want to show you something real quick. I also graphed these, and here's the answer for the first one, and you can see it was negative 2 and 6. And you might understand exactly what this is looking at. No, they won't let me. Oh, that's unfortunate. Oh, actually, I know what I can do. So, if I do this, let's see, and then, catch. Alright, so this was my first one. This is the line. This is the line. X equals negative 2. This is the line x equals 6. And remember, my solution set was, for the very first question, my solution set was negative 2 and positive 6. And my solution set for my second question was negative 6 and positive 2. And mere anything else. So one last one I want to do, and this last example is actually quite important. So let's take a quick look at one more. I'm going to make this one super easy because I want to make sure that you see it. This is kind of important that you do. We could have something like this. I could do the absolute value of x minus 3 equals a negative 5. Alright, so you might think, oh, okay, I know what to do. First thing I'm going to do is I'm going to isolate my variable, but I don't have to because there's nothing over here. So I'm going to write two equations. You might say x minus 3 equals positive 5, x minus 3 equals negative 5. And let's see what happens. If I add 3, I'm going to get x equals 8. And here, if I add 3, I'm going to get x equals a negative 2. And so you're probably thinking, oh, well, my solution set is negative 2, 8. But if I plug this in, that's going to give me a negative 2 and a negative 3, which gives me negative 5. And this is not true. So if I plug my 8 in, I get 8 minus 3, but that's supposed to be equal to negative 5 as well, and I get absolute value of 5 equals to negative 5, and once again, that's not true. And the reason why is this. The absolute value of x can't equal a negative value. Can't equal a negative value. Just like that. Because it's the positive distance away from 0. The only time this could actually, well, that's it. So anyway, that's it. Hope you enjoyed this video. I hope it makes sense.